Hello? You hear me? Can you hear me?
Hi, Corinne.
Hello, Corinne. Hello.
Hello, Carmelo. How are you?
Fine, thanks. And you? All fine?
Fine. Thanks.
Yeah.
Hello.
Hi.
Good evening.
I'm going to mute all the people, okay?
Okay.
Okay, so welcome everyone for this second day of the online workshop on operational oceanography. Today we have a very exciting program. We have a full session dedicated to the CMEMS system. We will hear from Carmelo Sammarco and Corinne Derval talking about the service, talking about the products and how to access them, how to use them. It will be a very practical session, as it is the idea of a workshop. So I will give the microphone to Carmelo that will start with the presentation. Thank you very much.
Hello, everybody. I don't know if you can hear me. Okay, yes. So my name is Carmelo Sammarco, and I'm going to give you an overview of the Siemens, so the Copernicus marine system, marine service. First of all, I would like to share with you a link so you can follow me easier in my presentation. Is important because especially after my overview of the Copernicus marine system, I'm going to give you a small workshop where I'm going to show you a few examples of data manipulation and visualization. I already put this link in the mail at 4:01 PM. So please, guys, try to, if you can, click on it. In the meantime, I'm going to start my presentation with some slides. So let's start. So first of all, what I would like to say is that the Copernicus Copernicus Marine Service is part of the Copernicus European Union Earth Observation Program, and this program is divided in 7 thematic streams of services: atmosphere, marine, land, climate change, security, and emergency. I work for the Copernicus Marine Service that is managed by Mercator Ocean. There is in fact many partnerships, and the Mercator Ocean is the one that is in charge of the Copernicus Marine Service.
Carmelo, sorry, I'm not sure if you are trying to show something. We don't see your screen. You must share your presentation.
Okay, sorry. So share screen.
Yeah, you must share the screen.
Yeah. I don't know.
It's in the window, a drop-down window, and you see share screen.
Yes. Yes. So. Okay. So share screen. Okay.
Exactly. Perfect.
Okay.
Perfect.
Okay. So sorry guys, I didn't realize that. So like I said, I hope that you follow me until now. Just to summarize again with the slide this time. I work for Mercator Ocean, and Mercator Ocean is in charge of the Copernicus Marine Service. Where I'm actually working. I work in the service desk, to be exactly. And the link to access this the Copernicus Marine Service is the following. This one. I'm going now to attach as well. It is one in the chat. So it's easy, it's easy to be used by you guys to follow me during my presentation, and I will try to understand where to. The chat, I don't find anymore the chat here. Okay, so I'm going to paste here. Okay. The really important things to say about the Copernicus Marine Service is that it tried to, of course, is very important for us, the user needs. In fact, we try to deliver all the service and product, the data, essentially, with the most quality possible, and as well with the most simplicity for us all to join all the targets of scientists or for personal use. And of course, it's a longer time that this is happening. And then there is a big knowledge base, and also there is many markets involved that benefit from this data, like we can see from the image here. And especially we can cite, for example, the climate, science and climate, the coastal monitoring, or natural resources, water, but many more. Anyway, we are going to go in details in this later on. Here, I just summarize what is the offer of the Copernicus Marine Service. Of course, Corinne is going to go more in details. Here, I'm just saying that we have essentially 3 types of data or products that are the observation, that essentially is like a fusion of different data collected by satellites and in situ observation. They have, yes, some processing, but a lower processing than the modeling, the models data. Of course, the models data require a much more algorithm and computational power. And of course, to do a model and then produce a forecast or a reanalysis, of course, there is needs of much more knowledge and integration with the marine reality. So of course, as much a sort of product that are much more complex to produce. In fact, we can see from this plot here in the presentation that in fact, we have the data from satellites that have, of course, the lowest data algorithm and the lowest knowledge base. After that, the product, the observation product, really in the middle, because already here the data was cleaned by impurities or instrument response, or it was converted like a gridded product. So they already have a sort of processing applied. And the most complex in terms of the algorithms and knowledge base and the knowledge of the marine reality, for sure, is the models. And then these are the most complex data, and also because I need to forecast in the future. And like that, of course, they are the much more computational, the most complex type of data. Another data really important is the ocean monitoring indicators. In these data are a collection of different variables like pH, temperature, sea level, and sea ice, and so on, of more than a quarter of century. These variables are really important to monitor many climate change that occur in the last quarter of century. And then it's very important to monitor the change in time. Another important product delivered by the Copernicus Marine Service is the Ocean State Reports. The Ocean State Reports is delivered every year, and is a collection of the most important discoveries and data. Is a sort of the summary of the year of the advance in the marine science. After that, to simplify, I would like to show you the web portal. So, like I explained, the three main categories of data and product delivered to the user are ocean product, ocean monitor indicators, ocean set reports. And like you can see, they are very good aligned in the main web page. If we want to know more, and we have an insight of what are all the services connected to this core of information, we can click here, for example, getting started. And from here, we again see the offer of the Copernicus Marine Service. And also we can access to different, we can have an overview of the different tools offered. For sure, there is a search. So we can search between all the products to search the best one that suits our research. We can search, and I'm going deep on the search in a bit. We can also visualize. So before download, for example, I would like to visualize a preview of some variables of some data in some particular region in the world. Well, we can do as well that. And I'm going to show in details this. And we can also, of course, download the data. But before download the data, we just require a registration that is totally free of charge. But we just ask if please the product, of course, can be seated. And essentially is the only things that we ask to download the data. is also important to know for us because we collect information about what is the most downloaded product, and that is can help us, for example, to improve our service to the users. So it's also to help the community to deliver a better download service. There is also many resources where you actually can learn also. It's not just data, in which data have its own documentation, but also here we are going to show you an example later. And if in case you have still some question and you are not able to resolve some problems for yourself, of course, feel free to contact us. In fact, you have a direct an email that direct arrive to the service desk, and we are always there to answer all the user questions. Also, we have also a forum, and this is very important because the community there can chat, and also we interact in the forum to help the user in many ways. If, for example, you have needs to know some information about a particular data or particular product, you can also use the new Flash. And if you have further let's say, question, you still are free to contact us, and we can give you all the information needed. The new Flash essentially are a collection of all the news about a product, and also sometimes we can highlight some issue with some satellites because overall is normal. They are like instruments, and then sometimes is we try to be more like real time possible to deliver to the user the best information and the last updated information about each product. Of course, we have also product improvements documentation, where actually you can see in time what to change for each product, the different resolution that each product can have, improvements also related to the addition of variables to data set. So this already is a more technical documentation that will be consulted as well in the website for free. Very important is the frequently asked questions. For example, if I open this page, we can see like here there is like already answered many questions that the user can have. And we try our best, of course, to implement this page with much more questions. We go from how to register, for example, how to see the data, that of course is very important to do. And as well, more technical one, like plot data in a GIS system, or how to load the load, the different type of the load. But anyway, now I'm going to speak later about each of these sections. So said that, finally, I think that now is the time to access the Ocean products, so the catalog. So this one is the catalog. There is a total of 171 products. And we can see that the search bar is in our left. Is a very complete search bar because you can search by words. So you can type here, I don't know, temperature or EB, and you are going to, for example, if you type EB, you are going to have all the products that contain the word EB, but it's not the best way to search. If you already know that you want to go in the EB region, of course, it's better already select the regional domain. So here we can select Iberia, Biscay, Ireland regional seas. After that, we can also decide which variables we are interested on. For example, we will see, I can be interested about temperature. And for the rest, we can also decide the temporal coverage, and we can also select just a product that have depth levels. So essentially, it's not just surface, but we have the 30 dimension depth. But for my research, I'm happy like that. And I, for example, decide that I am interested about this forecast. And then already from this page, I am able to see the few characteristics of this product. So I can see the product name. I can see what type of data is. In this case, is a model. and also from the name forecast, we can assume that it is a model. Here we can see in the fourth line, sorry, the variables inside this particular product, the resolution and the depth levels that this product have, in this case 50, the time availability, that in this case is just from 2018-04-01 until now, and the data in which way is delivered. I will explain better here. Essentially, the data can be, so every product can deliver data in many let's say, time steps. In this particular case, for this product, we can have that the data, so each day of data is divided by hours. So in this case, the data set will be called an hourly data set. We have also daily data set. So the data is essentially, there is one step for each day, one record for each day, and monthly mean, one record for each month. Like you can understand, of course, an hourly mean data set is much more heavier than a monthly mean data set, because of course the number of records, the number of hours in a month is more than just a record for just 1 month. So depending on what you need to do, of course, you can decide what type of data set you are interested on. Very important at this point, so this one is just a very fast overview of a few characteristics of this product. But if we want to investigate more, with more information about this product, so we can go to more info. In more info, we can then see essentially 4 tabs. There is an information tab where there is a more extensive product characteristic explained in details. So we have a short description, we have some reference to the product, the geographic coverage, and so on. And also very important, also we see information about, for example, the file format. Like we know, the standard nowadays for the satellite data is an netcdf. In this case, we have a netcdf3 that is just a type of netcdf file, a different type of compression. Anyway, this one is the topic at the moment. After that, the second tab is the tab, very important tab, because it's the tab where the documentation of the product, we can find the documentation of the product. In particular, we have 2 main documentation that we can consult. The product user manual that describe generic characteristic of the product, yes, in very technical details, because it shows the metadata, the structure of the metadata, the various the variables inside the product, the unit of measurement, if there is some scale factor to consider, and many more. But is the most technical document is the quality information document. And the quality information document is much technical, and also show the validation of the product and the different data simulated in case, and how is the data joined and then elaborated. So it's a much more in-depth view of the product. So depending what you need or your competences, you can decide to browse or the first or the second more technical one. After that, another very important tab is services. Services show the way that you can access the data, and also download the data. So we have both the link for the viewer, that is the VMS. But after that, you can see like another way to download that I'm going to show you in a second. At the moment, please just let me say in a very fast way. You can also download data using the subsetter. So you are going to be able to download the data, selecting variables, time, depth, and bounding box, geographic bounding box. And the direct get file in this case is not available, but the direct file is another download system that allow you to download the file just using considering the time window, so a time of your preference. And after that, FTP is another very important method, much used in these days. That is pretty well known. There are also many tools that can be used with FTP, like FileZilla, for example. But the FTP, of course, in this case, the data is downloaded and it's not possible to subset the data in any way. You download the full data. So it requires also space in your PC depending on the product. And like I said before, the new Flash allow you to see the news, live news about the product, improvements, or if there is some issue with some satellites, then there can be some problems in assimilation of some variables. So anyway, all is explained here. And this is very important, and we try to keep as much real time possible for help each user to keep updated on the product as much as possible. So at this point, I would like now introduce the add to cart. Add to cart can be possible selected by the information page, or as well if we go back in our research. So if we go just in the catalog and we browse again our product, there is also here, and usually is also useful this function because you can put in the cart the product you are interested on. So you can we see the product, and you can add to the cart. So you essentially take a note of the product that you can be interested. And after that, when you're ready, you can, for example, decide to visualize. And so clicking here allows us to access the viewer of this particular product. Like I said before, there are like 4 data sets inside this product. And for example, I would like to select the monthly mean field. Like you can see real time the data in the viewer. And also you can be able to select the variable of your interest. In this case is the water potential temperature at seafloor, but I can also, select salinity if I wish. For example, for salinity already you see like, for example, this green spot or, lower salinity spot, probably from rivers that, arrive in the sea in this point here. And the Mediterranean, for example, is more salty than the ocean. Just you already, have a vision of what the data is. It's very important that you can also change the scale bar. So please, if you're in the website, guys, you can try to change the scale bar and see what the difference can be. It can be useful, for example, if you want to highlight certain concentration of salinity or certain temperature, if you wish. So you can play with it and see what change. And of course, there is the chance to export the viewer like an image, export to PNG, and share a link, so a permalink. And also you can extract a CMEMS file, so a Google Earth file, and then overlap this to Google Earth if you wish. Of course, sorry if I didn't say before, you can also select the month. I decided to select the monthly data set, and then I am able to select different months in the time range available, of course. That, like we said, was from 2018 until now. And I think that with the viewer, I have nothing more to say, and I would like now pass to the very important area that is like the download of the data, to be able to store the data in your own PC. So to do that, we can click here in download the product. And so, like I said before, to download the data, we request your registration. That is totally free of charge. We just ask, please, when you use the data, to just cite the data that you're going to use for your research or purpose, general purpose. So I will log with an account already created, and at this point we can decide, because like you saw, we decided to download data about the same product that I viewed before. We can decide again the data set to download, and still I am interested to the monthly data set. So I am going to open the monthly data set, and soon here are going to show the different parameters that I can use to download my data. So if you're interested to subset and let's say extract some particular information from the data set, I suggest you to use the subsetter that can be done by the web portal or also by script. Here I will show you the web portal. During the workshop, I'm going to show you the script. So in the web portal is very straightforward, very intuitive. So here we can change our bounding box. So this one is the full extent, but of course we can also decide to decrease our extent. For example, we can decide to, we don't need all the portion of data available. We want just a bit of that, for example, like that. But sorry, this one is land. Actually, it's difficult to improvise with that. I was very unlucky to have land selected. I'm very sorry about that. But yes, we can also reset. And anyway, you can play with that. And you can select the area of your interest. And it's very cool that you adapt the viewer with the coordinates that you're going to input. So you can have a real vision of what you're going to take. After that, you can decide a time range. And in this case, it was just 1 month, for example. So I decided to have just this month here. This product contains depth information. And then I can, in theory, also decide the interval of depth that I want. In this case, I will just keep that I want just the most, the levels more close to the surface. And I can also check the variables that I am interested. And let's say that I am interested to the temperature. At this point, I can go here in the download options. And in download options, I can see the download systems available. So, like I said before, the parameters that I set before, geographic area, depth, and range of variables, are going to be applied for the subsetter download that can be accessed by clicking here, and then I can dynamically download this data from my browser, like I did now. Or I can do by script using this using Motu client that is a Python module that allow us to download from servers this data and subset the data. Anyway, about this we are going to see later. Another way to access this data is the FTP. And like we saw before, there was no availability to download this data with a direct get download. If there was available a direct download, we was able to download this data, but just using the time range. So to have a more precise type of subsetting is always suggested use the subsetter system using or web portal or Motu client by script. Now, another very important things that I suggest to you to browse that can be very relevant to let you understand in which way this data, satellite data, can be used in the real life. Sorry, guys. Is here, use case and markets. Here you can see again all the main markets that are happy to use our data. And especially if you go here in use case page, you can have an overview of all the use cases. And you can also browse using variables like geographic area or markets. For example, if you're interested in some particular market, here you can select your market of interest, user type, country, and as well if there is some mobile application that nowadays is, very used as well. Said that, I would like now start the workshop about this presentation. To do that, I please you to click on the link that if you didn't before to do now. I'm going now to upload my because expired. Sorry guys, I didn't think about that. So I'm going to put again the link of the Jupyter Lab. So is tiny cc / 2020-05-27. So please guys, if you don't do that, please do now. And now I'm going to give you an overview of what can be done with the Copernicus marine data. So finally here, yes, so is running. So for this workshop, I'm going to give before an introduction about both the data use and in which way set an environment. After that, I'm going to show you how to subset the data and download the data using our Python modules Motu client. And of course, I'm going to show reading technique and way to show the metadata, conversion of the data. In fact, of course, you know, the NetCDF is a very standardized way to keep this data, but sometimes, you know, for research purpose, of course, it's always good to know some conversion in the most famous about, I don't know, in CSV or shapefile can be very helpful for your research. Plot the data, and after that, I'm going to just show you in which way you can automate the plotting of this data. Also in which way you can realize some animation to show the change of a certain variable in time. Anyway, we start now to say that the data that I'm going to use for this workshop is a surface temperature data observation, and we need to specify that this product have two resolutions. So the resolution that we say here is the highest resolution, and is just for this data set. The other data set have a resolution of 0.25 degree. So please remember that when I go to download the data, I'm going to load the data with a resolution of 0.25 degree and then no 0.05. This one is an important information that we need for later. And of course, like we said, is an observation, is L4. L4 is like the processing level. In fact, there is a different level of processing. So a product can have a level 1 to level 4. Level 4 is the maximum. Of course, is let's say the maximum for the observation, of course. After that, we say already that is data that just is relative to the surface, is a gridded product, and then we need to expect that, of course, is georeferenced using this coordinate referencing system, as well, very important, especially if you work in GIS systems, like OneToGIS, ArcGIS. This information is very important. The temporal coverage, that, like we said, is from 2018-04-01 until now. The different data set included in this product, daily mean, monthly mean, and seasonal mean. And the updated frequency and the production unit, so where the product is produced. In this case, in Met Office, in Exeter. So to run our environment, like I said, there are this link that is connected to this Docker online. So you are able to play on the notebook with me, along with me. And that is probably the best and the faster scenario. Hopefully all you guys are able to log in inside. And there is as well like a regular Jupyter installation. In this way, you need to install, of course, in your local machine. And you can see this instruction from this link here. Like I said, we use Python because, of course, Python is one of the most used scientific programming language, but this sort of data can be read as well from other programming language. Anyway, I decided, and we decided to show you this in Python because it's still probably the most used language at the moment. So coming to us again, in Python, before start everything, Python require import the modules that need to be used. And then in this shell, remember that there is a difference between a shell like that is a markdown, and a shell like that is a code shell. So to run a code shell, that is what we're going to do, please select one shell like that, and you can push here run. So in this way, you can run this code cell, and when you see appears the number, it means that all the modules, so the command, was successful. So I imported all these modules. These modules are modules, of course, that allow us to do all the operation that you're going to see in the workshop. So convert in CSV, plot, make a different shape file, and order data. And then all this future you're going to see in a bit. So here, I suggest you to put your credential, username and password. Just use my credential that I'm going to be used for this workshop, if you have not one. So please, if you want, just copy and follow me. So the username is OMW account, and the password will be OMW 2020. So this one is still a code cell, so we need to run that. After that, like you can see here below, there is like the script used to subset the data. This is the same code that is suggested in the web portal. So just to be clear, when I went in the Ocean product and I went there to select and put in the cart our product, and then I decided to download this product, when I decided also the data set to use, in this case, I was deciding, I think the monthly, yes. Here, when I do download options, here I was able also to visualize a script sample to use to download the data for that type of particular selection that they did previously. This is a great help because allow you to have an example of what should be the structure, and plus you have here all the explanation about the usage, the different, let's say, way to write. And then you can essentially use this like model. So very important to know that if you are not very expert in writing this by heart, just go in the web portal, and from here you can take and you know, manipulate this to you know, your purpose. Also from here, you, for example, you can change a maximum minimum of longitude, latitude, depth. The important stuff that you remember, of course, to add your personal information, like the output directory, output file name, username, and password. And if all the fields are very well decided, then the download will be successful. Anyway, in the Jupyter lab here, the structure is that different because we need to run this like we are in a terminal. To do that, then there is some special symbols that can be used. I will not go in details, but anyway, with this exclamation mark, is like we say to Jupyter to run this command from the terminal. So, like you can see, we have the same field that you can see in the website. So we have the user, password, the Motu link, the service that will be the product name. We have the product key that will be the dataset used. And remember, the dataset that we are going to use for this download is not the one with the resolution 0.05 degree, but is the one with 0.25 degree of resolution. This one would be very important for later. And we download this data both for 1 month and also from the daily data set, and we download as well 30 days of data. So let's do that. So we run before the shell with username and password, then they can be read by the script that requests the data. So we can then download first the monthly data. Okay, done. And now we download as well the 30 days data. Probably will be a little bit longer because, of course, is more data to download. But it should be still very fast. Considering as well that all you guys are downloading, so right now the server probably will be, let's say, a bit busy. But anyway, like you see, it was very, very, very fast, pretty fast, considering all the potential people connected. Then, for example, we decided that we want to extract already some information from this data downloaded and then store in some variables. So first of all, we need to select the path where the data is stored. And this is done simply putting the data in this way. After that, to read, in this case, we use X-array. And then we are able with this array, using this formula here, to read our data and put inside is called dataset. So we put this data into the variable ds dataset. And if you explore the dataset, we already see few information about few metadata about the metadata about this download. That in this case is the monthly download that is called download Motu client NC. And from this particular data relative to this to monthly extraction, we extract the variable longitude, latitude, and the analyze ST. That is the variable that we are interested. So the temperature, So we run, and then all these variables, so longitude, latitude, analysis ST, are stored in these variables here. After that, it's a good habit when you finish to extract the variables from your data set. It's always good to close data set to improve the memory and don't leave let's say the data set open. The same we are going to do with the 30 days extraction that, like you can see, is called load mode to client 30 days to differentiate but the load mode to client that was just for 1 month. And then from here, we do essentially the same process. So we create the path where we can find the file. We read create then a data set that show essentially time. In fact, now is 30 time step because it's 13 days. Before was time 1 because it was just a month value of data. And after, like before, we close our data set. So at this point, we have all the information that we need stored and ready to be used. Anyway, like I said before, many times we don't want to work just with NetCDF, but we have the needs to convert in with other format, like for example, CSV or shapefile. I selected these two because CSV and shapefile probably are the most used format, or anyway are the very famous type of format used a lot in science and research and the companies. So to do that, I will show you in which way we can convert, for example, to CSV. So to do that, we are going to read the data still and put it in a data set. In this case, we are using still the monthly data. After that, this data set is needed to be converted in a data frame. Or what is the difference? That the data set, the data frame, show the data, organize the data in a tabular form. That is what we need, like the following. That is what we need for our CSV conversion. After that, once we created the data frame, we can process with the conversion to CSV. To convert in CSV, we process in two ways. Before, so we produce a CSV that contains as well all the data. Like you see, in some of the data, there is no, in some position, there is no value of data. So this can happen because, of course, we are speaking about marine data. And then if we have an area where there is as well some land, of course, all the grid points acquired in the land will be non-value. And then before, of course, so then we're going to generate essentially a CSV in this step containing all the value as well the non-values. After that, if we want, and in this case is important that we want to remove, for example, this non-value, so these inland data that are empty. And then with this function, the drop, we are able to remove such data. In fact, if we go in our data folder CSV, we running this cell, we created two CSV. One is called download mode to client CSV that show all the data, as well the one with no value, like we can see here, and another CSV where it actually is just with point that contain actually data. And this is very important, especially if you want to clean from non-values our data set. At this point, when this is ready, for example, if you need to convert the shapefile, then we can use TCSV clean by the non-available values, we can use this CSV to generate a correspective shapefile. So in this block of code, like you can see, I decided to create a shapefile, a punctual shapefile. In fact, the geometry is point. Of course, float, because the variables, like we saw here, is like a float, like you can see. And then the float is the most appropriate way to describe these variables here. And then, yes, with this, we are able to generate our shapefile. That will be a cloud of point, should be, that describe essentially the different acquisition in our area. And to be sure that we make a good shapefile, we can also interrogate the shapefile. So we can read the shapefile with the shapefile reader, and we can see that in total there is the total length, the total number of the point is 1,569. That should be essentially the same number, maximum number of the CSV that we generated. In fact, is the same without no variables value. And just we can show the first 10, let's say, point. Like we can see, this one is the first 10 records, just to show you an example of 10 records in our shapefile. So at this point, for example, we want to verify that actually this shapefile was generated correctly. So in this area, I show the code to plot the shapefile. So if I essentially run this cell, like we can see, I selected in our download, so before in our script, I selected an area that is like surrounded Portugal, Spain, and is very clearly visible here. Also, it's just red dot, but you can see essentially that all the non values probably was all the value in land, or anyway data that was not acquired by the satellites, and each dot represents the measurement of the satellites. Like you can see, every 2 degrees, we have essentially 8 dots, because the resolution of this product is 0.25 degrees, if like I said in the beginning. So from here, we can see that all is working perfectly, and our data is very well represented by this shapefile. Anyway, the shapefile is a way to plot the data. For example, if you want to do an interpolation yourself. But overall, the data can be already plotted using natively the netcdf file. And this can be easily done using, Python modules that allow you to, overlap your data with global maps, and you can select, of course, the feature that you would like to highlight. An example, for example, is here. So here, I decided to plot a global map, and I also decided to plot a polygon where actually our data is, where I decided to download our data. In the next plot, I'm going to show the same global plot, but this time I'm going to overlap the data downloaded. This one can be considered like a global scale view. Of course, many applications, and always probably is better have a more detailed scale, a local scale. To do that, at this point, we can decide then to plot a more precise and concise plot of our area of interest. Is a little bit slower because, of course, you need to create like a show more feature. So this one is a essentially zoomed version of what we saw here, and much more detailed. The data, sorry, I forgot to say that the temperature data, the analyzed ST data, natively in the dataset is expressed in Kelvin. That's why, of course, you see temperature so high. Nobody, I mean, but I understand that we are probably not used to work in Kelvin, and then I decided also to make the same plot in Celsius. Essentially, it's very simple because we just need to take the value of this 16 Kelvin minus 2073.15. And in this way, you are able to convert Kelvin and realize then a map in Gradius Celsius that is much more familiar to us. And like you can see, is very much more detailed. And as well, you can also play to change the scale if you want to play with the code to see what happens. Like I say to you to play a bit in the viewer. And really, is really powerful, these tools, Python, Jupyter Lab, to make this experiment. And I suggest everybody to have a play with it. Now, there is a very interesting part, because many times what happens is just a data, a monthly data. But many times we have a data set that, for example, contains 30 days, like I downloaded before. In this case, we want to plot 30 days, and we want to see the variation of this temperature in 30 days for this same region, because we want more precision in the variability in time in 1 month, rather than have a measurement for each month. And to that, I wrote for you this script that allows you essentially to loop between your NetCDF file of 30 days and realize then a plot for each day that is going to show soon, displayed soon. So this process, of course, requires some time because there are 30 days, and we have no probably time to wait until the end of this process. Or yes, depending the time. But yes, I think that I'm going to stop at some point. But like you can see, for each day, so in this case, it's 2020, 04, 01, year 04, 02. So for each day, I'm going to produce a plot. I left here the Kelvin temperature. Sorry if I didn't put here that it was Kelvin, but it's pretty clear from the value. And then now we are going to produce all the plot for all the months. After that, many times, so it's difficult in this way, probably realize the difference between the first and the last day. I mean, you need to browse too much between this figure. It can be very confusing. A simple way, also a nice way to show this data, for example, is to realize a simple animation of, sorry, I stopped the process because it was pretty long. Sorry, guys. So I can be nice, show this data like a GIF, for example, or a small animation. To that, I already previously generated these maps that should be inside this folder here, so PNG. Like we can see here, there is already all the image that was going to be produced by the process above. So these all images, of course, are going to be before read, after I'm going to sort, so from 0, that will be the first day of the month, the 29, that was the last day of the month, and then they are going to be incorporated to one single GIF file. So now the process starts. Okay, the process is finished. So in this way, I have my GIF file that I can visualize and show you using the following image here. Like you can see, the days here are moving, and in this way, you can visualize the change of temperature on SST in time for the month selected. And with this is everything. I hope that all was very clear. Thank you very much for your attention. And I hope that, like I said, all is clear. And if you have some question, I am happy to answer your question, both by mail or also now, if Flavio wish. Thank you very much.
Okay. Thank you, Carmelo.
Thank you.
It was a very nice lesson on how to use CMEMS data, how to download it, how to use Python scripts to take the best from the data. It was very illustrative, and also we can get the code and we can use it to evolve using this as a basis. It was very interesting. Thank you very much.
You're
So
welcome.
I would, before I pass the word to Corinne, I would make here a session of questions and answers. So if any one of the presents want to make a question, please raise your hand using the button in the participants window, and we will give a voice to you to ask the questions. Thank you very much. No questions? To raise your hand, you should use the button in the participants room to raise your hand. Oh, okay. Ana Barbosa. Anna,
Yes.
how are you?
I'm okay. I'm okay. Thank you, Carmelo, for the presentation.
You're welcome.
I have one question, because we have used CMEMS data in articles and also in classes in the university, but especially in respect with science. How are these products? How do these products compare with in situ data for very complex areas, such as those areas of Southwest Iberia, where we do have riverine discharges and high mesoscale activity with lots of eddies? So I would like to have your your ideas on this, if possible.
No, yes. If understood correctly, you would like to know better about in situ data, and in which way you can know information about what? Yes.
Yeah.
How, please, may you repeat?
Sorry, how do CMEMS predictions in respect, for instance, to mixed layer depths compare with in situ data for complex regions, such as those with high mesoscale activity, upwelling, riverine discharges, and...
Okay, of course, to do that, of course, there is a lot of experience that need to be required, and there is the production unit that, of course, is in charge to do so. And there is some production aspects that are, of course, very complex to, let's say, explain in details. I just can let you know that if you want to further details, you can just contact us in any moment. And for sure, I can allow you to have like a contact with a specialist that can clarify all your doubt about this complex area that I totally understand is a very complex system, and many times all this in situ observation are integrated as well with satellites information. So depending on the product as well, there are many options that need to be considered for the matter, because you can have a product that can integrate different data from satellites, data from in situ, or also algorithm used. So it's not just an answer that I can give in general. We need to understand what type of product you are going to use, and based on that, we can go to retrieve all the product information and the quality information from the tab that I showed you before. And from there, we're going to be able to understand in which way the product is done, all the characteristics of the product, the validation of the product, the data integration of the product. But this can be done for each product. There is no a single answer for all the products.
Yeah, of course.
All the product is unique, and is then really difficult to generalize in this particular case. What I can say is, of course, if you have some product that you would like to know more, you can also say to me now, and I can go directly live to show you the product documentation, and we can search together and answer together your question. Or I can, of course, take in charge, give you my contact of the service desk contact, so you can contact us, and in very fast, also tomorrow, we are going to give you all the indication of the case. The problem is that, like I said, I need to know exactly the product before to give you, let's say, some information, because there is also many products in the Arctic, in the also other complex area. There is not just one product, there is many products in the area that you mentioned.
Okay, thank you. I will probably contact you through Flavio. Yeah,
it's no problem at all. I will be very happy to, clarify all your questions about any product.
Okay, I must, of course, tell you that we have already contacted CMEMS several times, and we did get an answer. So just to let you know.
Okay.
No. Yes, I'm very happy about that. I'm very happy about that.
Anyhow, thank you.
No, you're welcome. You're welcome.
Okay, thank you. I guess one important message is that every product in CMEMS, as far as I could understand, have a quality report. So before you download the product, you can search for the quality of the product and read the report and so on. So that's an important thing, and obviously CMEMS is open, I guess, to answer every question.
Yes, in fact.
Okay, thank you very much. By the way, about the contacts of the speakers, we are updating the program, and we will distribute the program with the email of all the speakers. It was a lapse from us. It was something we missed, but we are doing a new program with the email of all the speakers, so everyone can then contact the speakers. So I will give the word to Pablo.
Good afternoon. Hello. How are you, Carmelo? Thanks.
You're welcome.
Okay, yeah, thanks a lot. I'm new with Copernicus. I'm trying to start to do science with this data, and we are already writing a paper and using of this data on climate change are very interesting. But I'm not doing it my own with help, because it's quite complicated to use all this Python for programming. The question is, we can solve people, because I am an R science. I use in R, and Python is new for me. And do you think we can solve all this programming using Panoply or Ocean Data View as a software to play?
Yes, sorry guys, because there are so many information that I gave that I totally forget to say that, of course, apart Python, R, there is other many tools that you can be able to see the data and browse the NetCDF file, like Panoply, Snap, also MATLAB. But yes, Panoply for sure, and Snap are the two probably more used because one is made by NASA, the other one, SNAP, is made by ESA, and they are pretty intuitive and give you the access to the let's see, the file. You can also convert in CSV directly from there. You can change the scale. You can select the depth. Are very, very well done. So yes, if you're not expert in programming, you can, of course, always contact us for each support that you can require if you need some help. But of course, you can also rely on these tools that are really important. Actually, thank you very much to bring this up, because I forget actually to say that these tools exist.
Okay,
And
thank you.
so thank you very much. Again, this question was very important. Thanks.
Yes, thank you, because I start with Python and it's complicated. And a second question, if we have time, a very short one, because Flavio explained yesterday very well the modeling and the dose scaling. There's the other thing that is maybe crazy, drive me crazy, the dose scaling. And can we use this data, for example, at the level of IL4 and a scale of 10, 100 kilometers without working with dose scaling, and just using the data we obtain from the products without remodeling the data in a dose scaling process?
Okay, so like you said, level 4 is just to say that the data have the most high level of processing. In particular case, yes, like you said, you take this data have a certain resolution, so it's your reference, it's gridded, and so on and so forth. What you say is actually, if you take data, you want to rescale the data. So you want to make you want to interpolate with the higher or lower resolution. I don't understand the question here. So no, you would like...
we are obtaining a resolution that is all right. I think is 0.0 degrees. That is a cool, it's a good resolution for us. But we are working with these pixels like that. We are not dose scaling or doing anything else. We are working with that resolution.
Okay, so in this case, yes, you can use this pixel to do your own interpolation. But the point is that you don't need to move the pixel. I mean, if the resolution is 0.25, for example, you need to know that you need to have 8 dots for each 2 degree. So if you maintain this resolution, you can do your own interpolation, yes. Will be, of course, a different visualization because there are different types of interpolation that you can use. Nearest neighbor, could be spline. There is a lot of interpolation that you can use to give different, also, you can visualize the data in many, many ways. So yes, you can keep shapefile, like I don't know, this should be cloud of points. You can do your own interpolation on QuantumGIS or as well ArcGIS if you wish. And in this way, yes, you have the correct data downloaded, but the visualization, of course, between the different interpolations can change. This one depending of the application, I suppose.
Okay, maybe I can add a little bit of about that, because as far as I could understand, the question of Pablo was if it would be efficient to do the interpolation instead of downscaling. And the thing is, Pablo, don't forget, when you interpolate, you get a nice picture, an interpolated picture, but you are not getting the processes, okay? So the processes are the processes of which were measured or simulated with that product, okay? So the thing is, you will not find new things by interpolating. So if you are trying to see, for example, very small scale processes, and you are using a low resolution data, you won't see those processes, even if you interpolate, okay? So that's something that you should, so the talk about the apple, it was about that. So a model is a model, and you cannot find something that is not in the assumptions of the model. Okay.
Thank you, Flavio, to the help.
Okay, so I will give the microphone to Paulo.
Okay, thank you very much. Thank you, Carmelo, for a very, very nice presentation. It
You're
was
welcome.
really interesting to see the code really running and see the hands-on practice. This is I feel that this type of exercise we are getting close to an environment where you could have a remote machine, a huge remote machine working with the data, and so you don't have to have a local. So it would be a distributed environment. And this raised me the question if are there any plans that the data might be available using some distributed access, say opened up or thread server, so that you are not obliged to download physically the data to your machine.
Yes, for sure. About that is, of course, in consideration to use OpenDAP. The point is that right now, the way to download is right now the subsetting system using multi-client, the web portal, direct get file, and FTP. OpenDAP is a work in progress, and is, of course, I don't know the time in which OpenDAP will be deployed. But I think that for some is already possible. So more details, if you want, I can give you more details. But right now I have no much more information because still is a pretty new way. There is no way. Is a new system that need to be implemented in Siemens. Is already implemented, I think, for some products, but not for all. And then, yes, like you said, will be great because, of course, in this way, you can operate the data without having the data in local. And this helps a lot because it is, plus the Jupyter Notebook, if you think, you don't need any more a bigger resources in terms of computer. So yes, will be a great revolution. And I'm really looking forward to see as well. Really, really very interesting what you said.
Okay, thank you very much.
Okay.
No, you're welcome. You're welcome. Thank you very much for the question.
Thank you. Before I pass to Corinne, I have also a question of myself, which is there any perspective in the future to have access to forecasts of the European Center of Forecasting Center, Weather Forecasting Center?
So, I mean, this data is, I think, used as well to forecast, of course, to the climate forecast. I mean, it's already possible access some forecast product, depending what you are looking for. Sorry, may you explain me better what data you are speaking about? Temperature or some variables in particular, or general forecast?
No, I was thinking, for example, forecasts of wind velocity. From
for example, if we go in live, so I am still live. So if I go in the web portal, for example, I can select all areas and I can select the parameters, for example, wind. And then if I set the parameters wind and remove the temperature, I'm going to see just the product that contains the wind variables. And like you see, there is observation, 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 observation. So at the moment, there is just observation.
Yeah, exactly. That was my question.
Yes, yes. I mean, very easy to answer, you know, when I have the catalog, because the products are so many that, you know, remember each one is always good search. Always good search in the catalog because the products are always updating. And then is very dynamic service, a dynamic products, always to improve, improve, improve. And then the products are constantly updated. Is always better search to be sure that, you know, actually, because they can change month by month, you know, there is always big update because we always care to keep the last technology, the best technology possible in realize this data. And then there is a lot of work behind. And then it's always better search to be totally sure. And also, if you find, it's better also read the product documentation, like you said before, to be totally sure that you are going to understand really the product is like feasible what you are planning to do with the data. So thank you very much to ask this question, but I always search the catalog before. Yes.
Okay, thank you. So now I'm giving the microphone to Corinne.
Yes.
I ask Carmelo, please, to stop sharing his screen. Yes.
Is it good? Okay. So good afternoon. I'm Corinne Derval from Mercator Ocean International, and I'm in charge of the Copernicus Marine Service catalog of products. First of all, thank you, Maria and Flavio, for inviting us from Mercator Ocean and for this very interesting and very well-organized online meeting. So I'm going to present you firstly an overview of the catalog of CMEMS products available on the Copernicus Marine Service web portal. Secondly, the detail of the different variables classified according to 3 groups: the blue ocean for physical parameters, white ocean for sea ice parameters, and green ocean for the biogeochemistry parameters. And thirdly, the ocean monitoring indicators. Finally, I will give you a summary of the main CMEMS product evolutions during this year. First, as Carmelo explained just before, the Copernicus Marine Service has one single portal, open and free. On the home page, there is an access to the CMEMS catalog of ocean products, an access to the ocean monitoring indicators, and also an access to the ocean state report. The catalog of ocean products contains today 171 products. There are 78 OMI. So before describing the content of the products, a few words on the ocean state reports, which you can also access on this page. The ocean state report is an annual scientific report that provides key reference information on the state of the global ocean and European regional seas based on the Copernicus Marine Service. This document is intended for the ocean scientific community as well as for policy and decision makers. The ocean state reports also aim at increasing general public awareness about the ocean component in climate change. And the fourth version will be published soon. So let's move to the Copernicus Marine Service and its main feature, a huge catalog of products. As I said, the CMEMS catalogs contain 171 products today and covering the global ocean and all European seas. These products are from 3 sources: in situ and satellites observations products and modeling products. The producers are organized by TAC, thematic assembly centers for observation products, and by MFC, monitoring forecasting centers for model products. So there are 8 tags: the sea surface temperature tag, the sea level tag, the ocean color tag, wind tag, and sea ice tag, delivering gridded product based on the satellite observation. The in situ tag delivering temperature, salinity, currents, biogeochemistry, and wave in situ observations. And the multi-ops tag, which combines satellite and in situ observation to provide 3D gridded global products. The MFC is covering the global ocean and all the European seas: Arctic Ocean, Baltic Sea, Northwest Shelf Seas, Iberian Biscay Irish Seas, Mediterranean Seas, and the Black Sea. The model configurations used in each area are tuned in terms of resolution, parameterizations, observations assimilated to optimize analysis and forecast in the area. And there are strong internal links between the TAC and the MFC, as observational data provided by TAC are assimilated by the models and used for validation. So all these production centers provide, first, near real-time products, including in situ and satellite observations provided by TAC. These products have different update frequency and delay regarding real time, and usually update frequency is daily. The MFC provide near real time analysis and forecast products. Analyses are updated on a daily or weekly basis, and the forecast lengths are most of the time 10 days of forecast. Secondly, multi-year products, which are reprocessed observations data provided by TACs, including optimized processing and quality check for period as long as possible, depending on the data sets, of course. And the MFC provide reanalysis, assimilating reprocessed observations and covering a long time period, mainly since 1993. And the ocean monitoring indicator are produced from the multi-year product and are yearly updated. So all these products are available through the CMEMS catalog that is regularly updated several times a year, with the addition of new products, improvement of existing products, and extension of a long time series. As Carmelo said before, for each product, product user manual and a quality information document are online available. These documents provide information on data access, formats, description of datasets content, and quality information with forecast skills, model observation comparison, processing, or instrumental errors. You can download these two documents on the website of the catalog. So now let's go into detail of variables. This is the list of the families of variables with the in situ, satellite, and model data. So in the following slides, I use the same legend with the colored stars, red for in situ, purple for satellite, and yellow for the model. So first, the parameters of the blue ocean. So that are the physical parameters: currents, temperature, salinity, sea surface elevation, surface wind, and waves. Model products, depending on the area, have a spatial resolution between 2 and 25 kilometers, temporal resolution ranging from 1 hour to 1 month. Real-time products are updated every day and deliver 10 days of forecast for most of them. Multi-year products cover the period since 1993 or sometimes longer. And regarding the characteristics of the observations, in the same way, it depends, of course, on the types of observations. There are L3 and L4 products with resolutions ranging from 7 kilometers to 25 kilometers. And the in situ products have a discrete spatial resolution. So just to precise, the L3 products are gridded data with gaps after validation process, and the L4 products are gap-free gridded data after validation process. So let's start with the variables of currents. Different velocity parameters are available for satellite model in situ products for all CMEMS domains. For example, the geostrophic velocity is provided by the sea level TAC, and the model provide total velocity that can include waves on tidal contribution, for example. So you can see on this table from which source, in situ, satellite or model, come each variable. And as illustration, an example of the surface velocity forecast provided by the EBMFC at 3 kilometers of resolution. And on the following slides, for each variable, there is also an illustration based on model or observation products. As an example, of course, it is not an exhaustive view of all the parameters. Then the temperature and salinity variables. We have surface temperature and salinity for the satellite data, on 3D fields for the models and in situ products, and the bottom temperature too for models. And the sea surface density and the mixed layer depths for all the area. And this is a plot of sea surface temperature L3 satellite observation. Now, the parameters of sea surface elevation. So the sea surface height for satellite and model products and mean dynamic topography fields are available for satellite data over all areas, CMEMS areas. And this is the sea level anomaly L for satellite observation. Now, satellite real-time and multi-year products of surface wind with the wind speed and wind stress parameters provided by the wind TAC. So are available at the global level in the catalog, with an example of the wind speed L4 satellite observation here. And the last group of variables for the blue ocean contains the waves parameters. These products also cover all CMEMS area. They are satellite, model, and in situ products on different variables as significant wave height, period, and direction. And here, an example from the EBMFC, the significant wave height forecast. Now let's move on to the sea ice product that describe the white ocean. Regarding models and observations, the spatial and temporal characteristics are very close to those of the blue ocean variables, so I will not repeat. These sea ice products cover the Arctic Ocean, Baltic Sea, and the global areas, including the Arctic and Antarctic Oceans. They are satellite and model products. Main variables available are sea ice concentration, thickness, and drift. And we have also a product that describe iceberg. Now, the green ocean with the biogeochemistry variables. As for the other group of variables described above, for the model observation, we keep the same characteristic concerning the spatial and temporal resolutions, and always, of course, according to the type of products. The families of chemical variables are the oxygen, primary production, the optical products with the transparency, turbidity, and the reflectance, plankton variables, nutrients, and the carbonate system. So first, the oxygen, the dissolved oxygen, available in model and in situ products on all CMEMS areas at different resolutions, depending on the MFC model, and discrete resolution that for the in situ products. With here an example over the EB area with the map of oxygen reanalysis coming from the reanalysis products. Secondly, the primary producers on low and mid trophic levels variables with the chlorophyll, primary production, phytoplankton, class and size, zooplankton, and micronecton. And these parameters are also variable over European seas and also for the global. And this is a map of coming from the global MFC. This is the micronecton reanalysis. And now the optical parameters, which are mostly satellite products, and also for the Arctic model, there is the light attenuation, and for from the Baltic MFC model that delivers the Secchi depths. With an example of the attenuation L3 satellite observation. Here, the nutrients parameters available for in situ and model products. They are nitrate, phosphate, silicate, iron, and ammonium data, also for all areas. And this is an example from the EB MFC with the nitrate forecasts. And finally, for the CMEMS biogeochemical data, the carbonate data that are listed here with the pH, the surface partial pressure of CO2, the surface flux of CO2, the in situ fugacity of CO2, and dissolved inorganic carbon and alkalinity. The last two variables are not yet available in all areas, but so the dissolved inorganic carbon and alkalinity will be at the catalog by the end of this year. Now, the ocean monitoring indicators. There are 3 downloadable datasets covering the past 25 years of the key variables used to monitor the oceanic trends in line with climate change. These indicators are classified by families. Currently, there are 10 families of OMI. There are the ocean health, the ocean heat content, the sea level, sea ice, North Atlantic climate variability, water mass heat exchange, currents, temperature and salinity, and the sea state, which is a new one planned for next July. Each indicator OMI family contains subfamily and that are mainly the CMEMS areas. For example, here in the ocean health family, if you click on the MEDC, you can access 2 indicators to their figures, short description, and for some of them, the data can be downloaded. Here I put on an example of an indicator on the EB area. This is the EB coastal upwelling index. On this figure, you can see the temporal evolution, the x-axis from 1993 to 2019 of the temperature anomaly along the coastline from North Africa to Spain, the y-axis. And so to finish, as I told you at the beginning of the presentation, the CMEMS catalog is regularly updated about 3 times a year. This year, there was a first release on last March, and there will be another one on July. So I'm going to present you the main evolution of the product regarding these 2 releases. on last March, main characteristics of the release were for the physical products, new Arctic tie-dye analysis and forecast products, new Baltic wave analysis product, the addition of wave spectra in global and regional in situ products, the inclusion of Sentinel-3B data in European sea surface temperature L3 product. Regarding the sea ice, a new Arctic sea ice thickness product based on a Cryosat-2 and SMOS data. For the bioproducts, the surface carbon variables are now available over the Baltic Sea for the model. And on last March, 14 OME has been added. And for next July, for the blue ocean products, a new wave reanalysis products for the European Northwest Shelf area, a new tidal solution on 10 days forecast for EB analysis and forecast products, HY2B data, the inclusion of HY2B data in sea level near real-time products and in L3 significant wave high global product, a new sea surface temperature L4 products over European seas, and the addition of wind field in L3 significant wave high global products. Regarding sea ice products for the White Ocean, a new standalone ice model for the Arctic from the Arctic MFC, and the addition of individual iceberg observed with Sentinel-1 in the Arctic Ocean. For the biogeochemistry products, the assimilation of the chlorophyll in the Black Sea MFC systems, the introduction of nutrient in situ global reprocessing, and a new global reprocessing product of 3D particulate organic carbon and chlorophyll. And a temporal extension of some multi-year products to get closer to near real time for most of them. And for OMI, next July, the addition of a sea-state family with anomaly and mean extreme variability of significant wave height for European seas. So this is my last slide. You can find at this address the roadmap for the ocean products, the evolution of the products in the catalog, the OMI, and also the service improvements on the CMEMS website. This page is regularly updated, and the main improvements are listed here. So thank you for listening. If you have a question.
Okay, thank you, Corinne.
Thank you. I was afraid that I lost everyone.
Presentation. I guess you. Thank you. We have time for questions, so please raise your hand if you have questions for Corinne, or even some lost question you would like to ask.
Just can I add something, because I saw a question on the chat a few minutes ago.
Yes,
and
yes.
Maybe I can answer it. Somebody asked for the static files like bathymetry, and I forget to precise that for all the model system in the catalog, we delivered the static files that contain the mask and the bathymetry fields.
Okay, that's very important. Thank you.
Thank you.
So any question, please raise your hand and I will give you the microphone. No questions? I will wait 1 minute or two just to be sure no one is searching for the button. So the button is in the participants window to raise your hand. Okay, so I guess there is no question. Anyway, Corinne, thank you very much for this very interesting presentation. So this was the session of today, very interesting session with very practical also, because it was possible to see how to use the data. Usually we see the menus and we see where the data is, but we don't learn how to use it. And when we start trying to use it, it's really difficult. But this was a very informative session. So this is the nature of a workshop. Thank you very much to both of you. So tomorrow we have a session with examples. So basically we have been moving from basics to data and now to application of that data. So tomorrow we have 5 different companies that use this data in different ways for different purposes to give added value to the society. So basically all our efforts, both at the academia, at the universities and in institutions like Mercator, the final aim is to provide help to the society. So we'll see tomorrow a few examples of the utility and the use of this kind of data. So thank you very much to all of you, and we meet here tomorrow for the final session.